All right, let's get right into it. It's easy to think of soldering as just heat, melt, and you're done, right? But what's the real difference between a quick patch up and a professional repair that's going to last? Well, today we're going to break it all down. We're talking about soldering as a real craft, one that's built on 5 absolutely essential pillars. Get these right, and you're guaranteed a perfect joint every single time.
So here's the game plan. These are the 5 pillars we're going to walk through. We'll kick things off with the hidden science behind it all, then cover the safety stuff you just can't skip. After that, we'll get into reading the blueprints for success, master the art of prep work, and wrap it all up with that crucial final inspection. Master these 5, and you've basically mastered the craft. So let's kick things off with a big question. When a solder joint fails, what's really going on? What's the true culprit? Is it the solder itself? The iron? The truth is, it's usually hidden in the details, and it almost always starts with the science that, let's be honest, most people just skip right over. And that leads us perfectly into our very first pillar, soldering's hidden science. See, before you even think about plugging in that iron, you've got to understand what's happening on a microscopic level. It's not just melting metal, it's this precise dance of metallurgy and chemistry.
Okay, say hello to the #1 enemy of any good electrical repair, the cold joint. Now, the scariest part about this is right there on the slide. It often looks acceptable, and that's what makes it so sneaky, so dangerous. It's basically a ticking time bomb. It might pass a quick look over, but secretly it's a point of high resistance, just waiting for the right moment to fail.
And this comparison just lays it all out perfectly, doesn't it? Over on the left, you've got the good joint. It's shiny, smooth, with that nice concave curve. The solder has properly wetted the surfaces, creating a genuine, strong metallurgical bond. But then you look to the right, and that's our cold joint. It's all grainy and balled up. It's just sitting on top of the metals, basically bridging the gap without really connecting anything. So how do we get that good joint every time? Well, first, the solder has to actually flow into the gap and bond with the metal, not just sit there. And that's where flex comes in. Think of it like a chemical cleaner that just scrubs the surface clean and, most importantly, prevents oxidation, which is the absolute enemy of a good bond. And here's the other crucial part. That joint has to be held perfectly still while it cools down. I mean, absolutely motionless. Any little jiggle creates those tiny fractures that are the signature of a cold joint. So why are we so obsessed with this? Well, the stakes are pretty high. As this quote spells out, a bad joint creates massive electrical resistance, and that can lead to all sorts of nightmares, like intermittent faults that you'll pull your hair out trying to diagnose, voltage drops that can starve components of power, or, and this is the scary one, it can generate enough heat to actually cause a fire.
Okay, so with all that science fresh in our minds, let's move on to our second pillar. Safety. And look, this isn't just a boring list of rules. This is about treating safety as your #1 tool, the very first one you pick up before you even think about the others.
And just to give you a little perspective, take a look at that number, 300 to 450 degrees Celsius. That's how hot your iron is running. That is way more than enough to give you a nasty burn or ignite something flammable in a split second. You've got to respect the heat. So here's your safety checklist before you even start. Think of it like a pre-flight check. First up, know what you're working with. Read the safety data sheets. Next, ventilation. You gotta have it for those fumes. Always, always use the right personal protective equipment. And before you even plug anything in, you need to know exactly where the fire extinguisher and the first aid kit are. Seriously, these things are completely non-negotiable. And hey, if you're thinking the whole fume risk thing is a bit overblown, think again. This quote really drives the point home. Occupational asthma. That's a serious, life-changing condition. These are not just theoretical risks, especially in a busy workshop where you're exposed to this stuff day in and day out. All right, on to pillar number 3, blueprints for success. A real pro doesn't just wing it. They work from a plan. And that means you have to know how to speak the language of the job. And this isn't just about connecting wire A to point B. It's about being fluent in electronics. Can you actually read that wiring diagram? Can you correctly identify the wire gauge you're looking at? Are you picking out the right type and, just as important, the right diameter of solder for this specific job? Look, the manufacturer has specs for a reason. Your job is to know them and to meet them. And getting this stuff wrong, it has real-world, professional consequences. You misread a gauge, you could cause overheating. You pick the wrong solder, you get a weak joint. These are exactly the kinds of simple mistakes that cause a repair to fail a compliance inspection. And that means a failed job and a big hit to your reputation. Which brings us to what I personally think is the single most important pillar of them all. Pillar number 4, prep for perfection. I'm telling you, this is where most repairs are either won or lost, way before the solder even gets near the component. Just look at this simple 3-step path to success. Number 1, clean everything, and I mean perfectly clean. Get rid of all oxidation, all grease. Number 2, secure the joint. It has to be locked down so there is zero movement, not even a little wiggle during soldering and cooling. And number 3, prepare your iron. The tip has to be clean and properly tinned so you get perfect heat transfer. I promise you, if you nail these 3 steps, the actual act of soldering becomes the easy part. And this quote right here, this is pure gold. It's the voice of hard-won experience. The rookie always blames the soldering iron. The pro blames the prep work. The vast majority of failures come back to one of 2 things, a contaminated component or a joint that moved while it was cooling. Get the prep right, and you're already 90% of the way there. And at last, we've arrived at our 5th and final pillar, the final inspection. Remember, the job isn't over when you put the iron down. It's only done when you've actually verified the quality of your work and made sure it's protected for the long haul. And this table is basically your visual cheat sheet for quality control. An acceptable joint, it's smooth, it's shiny, and it has that classic concave profile we've been talking about. The solder looks like it just flowed right onto the conductor and became part of it. An unacceptable joint, on the other hand, it just looks wrong. It's balled up, it's grainy, it looks like it's actively trying to pull away from the wire. Trust me, your eyes are one of your best inspection tools here. But hey, after that visual check, there is one last absolutely critical step. Don't forget the insulation. A bare solder joint is just an accident waiting to happen. A truly professional repair is always sealed up, usually with the right size of heat shrink tubing to create a tough weatherproof barrier. And why is this so non-negotiable? Because an uninsulated, exposed joint can short out against anything conductive it touches. That could lead to something as simple as a blown fuse, or something as catastrophic as a fire, or a complete system failure. Skipping this one final step can turn a perfect repair into a dangerous liability. So, as we wrap all this up, I want to leave you with this one thought, this one question. When you finish a solder joint, are you just finishing a task, or are you leaving your signature behind? A mark that's a testament to your skill, your knowledge, and your absolute commitment to doing the job right. Because that, right there, is the difference between an amateur and a true professional.